All right, welcome everyone to some probability time. We're going to be discussing some probability kind of before and after, or sometimes what we call in math theoretical versus experimental. So we'll dive right in and just spend a couple minutes on this. Let's see. Let's start with a counter. We've got here a red and yellow counter. Get some of these other items out of the way for now, and what we're talking about when it comes to experimental and theoretical probability is talking about the before, and the experimental probability is talking about the after. And like we're holding an experiment. We've got a theory beforehand, but then we do an experiment and we get the answer. For example, on this chip, this counter chip, it's got a yellow and a red side. What's the probability that when I flip it, it's going to land on red? What's the probability there? Well, the probability of red, theoretically, there's two options, and one of them is red. So the theoretical probability is 1/2 or 50%. The experimental is what happens when I do it. So for example, if I do this 4 times, let's see, red. Okay, so I got a yellow. I'm going to kind of keep some notes here. A yellow, a yellow, a yellow, and a yellow. Whoops, I don't know if it's yellow. It is, I'll just show you. It's red. Just so you know, I did get one red. So on that one, the experimental, the probability of red on this one, when I did the experimental, I got 1 red out of 4, which is 25%. Well, that's kind of a big difference. Just know that the theoretical is talking about before. It's what we expect to happen. Experimental is what really does. I could, if I wanted to, I could do this again, and I could, let's say that I want to flip it 10 times. And I would get a certain number, 1, 2, I could really spend a lot of time doing this. My theory out of 10 is that I would get 5. The 50% is the theory of red. When I actually do it, when I do the experiment, when I actually have it occur, what's this number going to be? Well, it'll be close to 5. This 1 was close to 2 to make 1/2. It might be 6 or 7 or 8, maybe 4, 5 or 6 maybe, but it may not be exactly what the theory was. Same thing with rolling a dice. What's the theoretical? Let's say what's the theoretical probability that I'm going to roll a 6? We've learned about this. There's 6 options on a die, and one of them is a 6. So what's it actually going to be? When I roll the dice, should I roll it 12 times? And how many times is that going to be a 6? Let's say I'm going to roll it 12 times. This percent is about 16%. We're now going to see the actual. So I'm rolling a dice. We've got, okay, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I've got 1, 9, whoops, 10, 11, 12. When I rolled it 12 times, oh my goodness, I actually did get 2 out of 12. It actually was 1/6. My experimental percent was exactly the same as my probability. But that doesn't always happen. And if I did this maybe, let's say if I rolled it 1,000 times, I might be really, really close. Because the more you do it, the closer you get to the theoretical or what the predictable outcome is, as long as it's a random event. You can do this, like I said, with counter chips, with dice. I recognize that with cards, not everybody knows, not everyone spends time with cards, which is probably a good thing. There's 4 different suits. There's a There's a spade suit, like that. There's a heart suit. There's a club suit and a diamond suit. And so on those 4 suits, what's the, if I pick the cards, what's the probability that I'm going to get the heart? Well, there's 4 suits. It's all equal, and one of those suits is a heart. If I wanted to show you exactly, there's 13 hearts out of the 52 card deck, but it's the same thing. It all equals 25%. So let's do this. Let's pick hearts and see how many. What does I'm going to pick 4 cards. And when I pick these 4 cards, which of these, how many times am I going to get a heart? Let's get these nice and shuffled. Try to make this nice and random. Pretend I have no idea what's going on here. There we go. Okay, so I'm going to pick 4 cards and see how many hearts am I going to get. Well, let's see. Okay, I got a spade. That was 1. I'm going to mix them all up again so I get as random as I can. Each time I'm picking out a 52. Here's my second pick. A diamond, okay. So no hearts yet out of 2 picks. Shuffle them up again. Here's my third pick. Let's do this one right. There's a club. So far I've gotten 1 of every one. Is it going to be 1 or 0 with the hearts? What's it going to be? Well, let's see. I'm going to now get this last one is a spade. So my probability out of 4 was 0. 0% of them for cards. All I would have needed was just 1. Let's say I pick another one out of 5. What if I pick another one? And it ends up being a heart. Then I'd be at 20%, which is close to the 25. Let's say if I pick 1,000 of them. If I do that, it really will be close to 250 of them that were hearts. That is what happens. So just know that in all these probabilities and doing this work, the theoretical is before we have the event, and the experimental is after the event. Okay, there you go. Thanks for watching. I hope it was helpful, and I hope there's a 100% chance that you have a great day today. Bye-bye.